Let us now see the second example for oxygen, O2. Let us see the electronic configuration for oxygen atom first. K, L, L shell. So oxygen has atomic number 8. So when this 8 electrons now has to be distributed in the shells. So we know that in K shell only 2 electrons can be accommodated. So out of 8, 2 electrons goes in the K shell. Now from these 8 electrons, how many electrons are remaining? 6 electrons are remaining. And we know that in L shell, 8 electrons can be accommodated. So easily in the L shell, 6 electrons will be placed. And as I have also told that, only the last electron, only the last shell participate in bond formation. The first shell has nothing to do with bond formation. So it will remain as it is. Only this will come into play. That means only this will participate in bond formation. Now let us see how 2 oxygen forms bond. We know that one hydrogen atom has 6 valence electron. So whenever we are placing the oxygen electrons, we will place only the valence electron. So here 1, 2, 3, 4, 5, 6. Placing of electrons should be done in such a way that they can easily form bond with the other element. So now it has 6 valence electrons. So we will start placing it. 1, 2, 3, 4, 5, 6. First valence electron has been placed for the first atom. Now let's place for the second atom. This also has 6 valence electrons. So 1, 2, 3, 4, 5 and 6. Or you can, if you are getting confused, you can also represent it as X so that there will be no confusion. 1, 2, 3, 4, 5, 6. Now both of these oxygen needs to attain stability. Now how will they attain stability? By sharing of electrons. Now this oxygen has 6 electrons. It needs 2 electrons to attain stability. Now these oxygen atoms tell this oxygen atom that I will share 2 of my electrons with you. You also share your 2 electrons so that we will attain stability. Now both of them agrees and they start sharing their electrons. This oxygen gives its 2 electrons to this oxygen. Now you see how many electrons are present for this oxygen. 1, 2, 3, 4, 5, 6, 7, 8. So it has attained stability. And now this oxygen also shares its 2 electrons with this oxygen. Upon sharing of electron, you can see that this oxygen atoms also has 8 electrons altogether. 1, 2, 3, 4, 5, 6, 7, 8. So both of them has attained stability by sharing its electron. And we can see that how many pairs of electron has taken part? 2 pairs of electron. 1 pair of electron has 2 electrons. So 1 pair of electron gives single bond. 2 pairs of electron, that means 4 electrons, will give double bond. So here, since 2 pairs of electrons are participating, we can see that double bond will be formed between 2 atoms. That means 2 oxygen atoms are held together by double bond. This double bond is known as double covalent bond. We have studied about single covalent bond and double covalent bond. Now let us see for a triple covalent bond. Let us take an example of nitrogen N2. Nitrogen configuration is, nitrogen has 7 electrons. These 7 electrons will go and accommodate in the shells. Out of 7, 2 electrons will go and sit in the K shell. And out of the 7, how many are remaining? 5 electrons are remaining. So 5 electrons will go and sit in the K shell. Now let us see how these two nitrogen atoms will form bond. One nitrogen and the other nitrogen atoms. And as I said, only the last electron will participate in bond formation. So here 5 electrons. 1, 2, 3, 4. You can place as you want. 4 and 5. Same here for this nitrogen. 1, 2, 3, 4 and 5. So similarly as the two atoms we have discussed, this nitrogen also through mutual understanding and mutual sharing they form bonds. This nitrogen agrees to share its 3 electrons because now they have 5 electrons and they need 3 electrons to become 8. That means to attain stability they need 3 more electrons. So from here this nitrogen agrees to share its 3 electrons with this nitrogen. This nitrogen also agrees to share its 3 electrons with this nitrogen. So now they start sharing of electrons. Now you can see that how many electrons are present for this nitrogen. These 3 electrons belong to this nitrogen, but this nitrogen has agreed to share its 3 electrons. Why? Because each of them needs 3 electrons to attain stability. So now you count the electrons for this nitrogen. 1, 2, 3, 4, 5, 6, 7, 8. Now it is 8. It has fulfilled the octet rule. It has become stable. Now the turn comes to this nitrogen to attain stability. So this nitrogen also agrees to give its 3 electrons to this nitrogen. So now upon sharing of electrons, what happens is this nitrogen also has 8 electrons now. 1, 2, 3, 4, 5, 6, 7, 8. This also has 8 electrons, which is 1, 2, 3, 4, 5, 6, 7, 8. So both of them has attained stability. How did they attain stability? Through sharing of electrons. How many pairs of electrons did they share? They shared 3 pairs of electrons. Each pair represents one bond. So in case of nitrogen, 2 nitrogen atoms are attached by a triple bond. This triple bond, it is known as triple covalent bond. Now we have seen the formation of single bond, double bond and triple bond. They are all formed by sharing of electrons, and bond formed by sharing of electrons is known as covalent bond. I'm sure by now it will be clear about how covalent bonds are formed and how sharing of electrons takes place. If there is still confusion, you can always approach me. Now, in your textbook, there is a very small portion for allotropes. This is not a very important topic, but we will just discuss in brief. Allotropes. What are allotropes? Allotropes are compounds formed by the same element. They might have the same chemical properties, but they differ in their physical properties. Once again, they will have the same chemical properties as their parent compound, but they will differ in their physical properties. Carbon is so versatile that allotropes of carbons are present. The two allotropes which you need to remember is diamond and graphite. Diamond and graphite are the two allotropes of carbon. Let's not go into very much detail in this topic, but just remember what are allotropes and allotropes of carbon. Now let us see some versatile nature of carbon. Carbon, it is so versatile that all living organisms have carbon. Even petroleums are made up of carbon. Even plastics have carbon. Everything that you see around has some or the other quantities of carbon. So carbon is so versatile. That is why there was a need to understand and to study carbons. Now let us see the versatile nature or versatile properties of carbon. The first property that we will study is tetravalent. Carbon is known to be tetravalent. Why? Because we know that the electronic configuration of carbon is 2 and 4. And we also know that last shell is known as valence shell and the last electron is known as valence electron. So tetravalency, tetra stands for 4, valent means valency. So this says that carbon has tetravalency. Why is that only carbon has tetravalency? Why not other atoms? Other atoms also has 4 electrons in their valence shell, but the only difference is that they have that much energy that they can either transfer its electron or accept electron. But carbon do not have that tendency. Carbon only shares its electron without giving away its electron permanently. So this tetravalency remains for carbon always. What is the use of this tetravalency? That means that carbon has 4 electrons in its outermost shell. So whenever carbon forms any compounds, it will always maintain its tetravalency. Whenever carbon forms compound, it will always have 4 bonds. You will never see carbon having 3 bonds, or you will never see carbon having 5 bonds. These are all wrong. You will always see carbon will have only 4 bonds. Let me give you one example how tetravalency will be maintained. Suppose there are 3 carbons, all attached by a single bond. Now, as we know that carbon needs to maintain its tetravalency. So, here this bond has been shared by even this carbon, and this bond is being shared by this carbon as well as this carbon. So whenever we talk about tetravalency, we count their bonds. That means how many bonds are present. And always carbon should have 4 bonds. So here, for this carbon, how many bonds are there? Only 1 bond. That means it needs to have 3 more bonds to attain the tetravalency. So it needs to have 3 more bonds, where 1, 2, 3. Now check for this carbon, how many bonds are there? 1, 2, 3, 4. So tetravalency has been maintained. Now this carbon, how many bonds are there? 1, 2. How many more bonds does it need to attain tetravalency? 2 more bonds. Now count for this carbon, 1, 2, 3, 4. So there are 4 bonds now. This also has attained tetravalency. Now count for this carbon. This carbon has only 1 bond now. So how many bonds does it need? It needs 3 more bonds to attain tetravalency. Carbon, whenever it forms any compound, it will always firstly maintain its tetravalency. If it's not maintaining its tetravalency, the entire formula will be wrong. So always whenever you make a carbon compound, make sure that the tetravalency has been maintained. This is how the tetravalency should be maintained. Now the second property and a very versatile property of carbon is catenation. What is catenation? Catenation is the self-linkage property of carbon to link with its similar kind of atoms. That means carbon has a tendency to link with similar kind of atoms. You will never find any atoms having this catenation property. That means you will never see hydrogen bonded with just hydrogen. But carbon has this unique and very good property of catenation. With the help of this catenation, they may even form chains of a straight chain, or it may be branches, or it may be even ring shape. Now let us see how this catenation is done in case of carbon. Carbon has this unique property of catenation. That means it starts linking up with its same kind of atoms. Now let us see a straight chain of carbon. We are just taking 4 carbons, it may be any number. Now we are maintaining the tetravalency. I have already explained how to maintain the tetravalency. I'm sure it should not be a problem by now. So this is a straight chain of carbon. Now let us straight chain. Now let us see a branched chain. Now also we will take up only 4 carbons. Branched means carbon will be placed upside down or anywhere so that a branch is formed. So here carbon. Now see, this carbon needs to maintain its tetravalency. That means it needs to have 4 bonds. It already has 1 bond, so it will again have 3 bonds more. This carbon has already 2 bonds. It needs 2 more bonds to attain 4 bonds. This carbon, you count the bonds. 1, 2, 3. 3 bonds already, so it just needs 1 bond. Even for this carbon, you count the bonds. 1, 2. So it needs 2 more bonds to attain tetravalent. Now count for this carbon. It has only 1 bond. So it needs how many? 1, 2, 3 bonds. So that it becomes tetravalent. Now here also this carbon has just 1 bond. Now it needs how many bonds to attain tetravalency? 1, 2, 3. These are not joined. So this is how a branched chain is formed. Straight chain and branched chain. Even carbon has a tendency to form a ring. Just in this case, carbon, carbon. Now you see these are carbon ring. This is also known as cyclohexane. We will study about naming, so don't worry for now. Cyclohexane. Now as I said, we need to maintain the tetravalency. So this carbon has 2 bonds, so it needs 2 more bonds to become 4. Same with this carbon, it has 2 bonds, so we need to put 2 more bonds. Here also 2 bonds, so we need to put 2 more bonds. Here also 2 bonds, we need to put 2 more bonds. Here also when we count, we find that there are 2 bonds, so in order to make it 4, we need to put up 2 more bonds. Here also the same thing follows. We already have 2 bonds, so we will put up 2 more bonds. So tetravalency has been maintained. So this is how carbon has this catenation property of forming chains of straight chain, branch as well as ring. I am sure by now it is clear about catenation. The last property which we will study about this versatile nature of carbon is multiple bonding. Carbon has a tendency to form multiple bonds. That means single bond, double bond and triple bond. Now this bond formation can be done with any atom. This is X represent nitrogen or chlorine or oxygen, anything, not hydrogen. Carbon cannot form a double bond with hydrogen. Neither can it form a triple bond with hydrogen. It can form a single. It does not form bond with hydrogen. It can form bond with another carbon atom or any other atom such as nitrogen, chlorine or oxygen. Or the other way is that it can form bond with its own atom, that is carbon forming bond with carbon, carbon double bond with carbon, carbon triple bond with carbon. Now this single, double, triple bond, carbon has this multiple tendency to form multiple bonds like single, double and triple. This single, double and triple are also categorized in another form, that is this single bond is known as saturated and this double and triple bond, it is known as unsaturated. Saturated means they are already stable. They already have a single bond. Unsaturated means they are not stable. They need to have bond breakage so that they become stable, so that they become saturated. Another way we can say that unsaturated means addition reaction can take place so that they become saturated. Unsaturated are those which resist addition reaction because they are already stable or saturated. These saturated and unsaturated are further categorized as alkene, alkane and alkyne. Now, before we move to alkene, alkane and alkyne, know that we are also talking about hydrocarbons. What are hydrocarbons? Hydrocarbons are those which are made up of hydrogen as well as carbon. They may either have they will always have carbon and hydrogen, and also they may have some other atoms or elements present in it. But the presence of carbon and hydrogen is a must for a hydrocarbon. Now if we see carbon dioxide, CO2, we don't see the presence of hydrogen here. So this is not a hydrocarbon. But CH3COOH, that is acetic acid, we see that carbon is present, hydrogen is present along with a functional group. Functional group also we will be discussing. So we see that carbon, hydrogen is present with some other group. So that means this is a hydrocarbon. Hydrocarbon means it will simply have carbon and hydrogen. Otherwise it will have carbon, hydrogen with presence of some other group. So hydrocarbon simply means those compounds which are made up of hydrogen as well as carbon. Now we will be seeing the saturated and unsaturated categories, which are further classified into alkenes, alkanes, alkenes and alkynes. Alkane means those which have single bond, alkenes means those which have double bond, and alkynes means those which have triple bond. Alkenes come in the category of saturated. And alkenes and alkynes, that is double and triple bond, comes in the category of unsaturated. This saturated has been given the name alkanes. That means, just remove the S. It is okay to put, but in order to avoid confusion. So, the difference is only in the three letters present at the last, that means the suffix. Suffix means those words which are added at the last. So, the difference in all these three are only the last three letters, which is A and E, E and E and Y and E. The difference is only in the suffix. Alkane, alkene and alkyne. Remember that alkene is a single bond, alkane is a single bond, that is A and E. Alkene, E and E is a double bond, and Y and E is a triple bond. And single bond is known as saturated, double and triple bond is known as unsaturated. We will discuss about alkene, alkane and alkyne in details with their members in our next session.